Good evening. Tonight we're going to discuss how do we measure the volume of an object. There are two ways to measure any substance, either directly or indirectly. Okay? When discussing indirect measurement, or what we call the displacement method, you are not measuring the object itself, you are actually measuring the object's effect on another substance in order to gain some information about the original object. All right, follow me with this. For instance, here, if you have an irregular shaped object like a rock or a bolt or a key, something that doesn't have lengths, widths, and heights that are equal, as in the example before with the box and the rectangle bar. So you can't determine the actual volume because of the different bumps and crevices on its surface. So since you can't determine the amount of space it takes up by measuring its equal sides, or its length, its width, and its height, and multiplying them, you can determine how much space it takes up by measuring the amount of water or liquid that it displaces when it's placed in a graduated cylinder. So as long as the object sinks, it's going to take up the space that where that water or liquid would have been. So you can see here when we started this measurement, the liquid was lower. When we dropped the key in, it sank and forced all the water molecules up, which is called displacement. It displaced or moved those water molecules. It pushed them up the graduated cylinder. The same thing happened here. We started with about 200 milliliters of liquid in the graduated cylinder. When we dropped the rock into the graduated cylinder, it took the place of all the water molecules at the bottom and pushed them up. And it pushed them up to the 260 milliliter mark. So the rock displaced 60 milliliters of water. So the volume of this rock is 60 milliliters. The way we calculate that is we record the final volume in the graduated cylinder and we subtract the initial volume in the graduated cylinder. So it'd be 260 milliliters minus 200 milliliters, and that gives us a volume of 60 milliliters for the rock. So we are measuring that indirectly. We're not actually measuring the object itself. We're actually measuring the displacement of the water. All of this water was displaced. As you can see here, the same thing. All of this water was displaced. You have to make sure during this method that you have enough water in the graduated cylinder so that when the object is placed in it, it can sink completely. If the object is too big to fit into a graduated cylinder, you can use a piece of apparatus, a piece of equipment called an overflow can. Okay, an overflow can looks like this. The concept is still the same, but you can see here that the opening is larger, so you can fit larger objects in it. Basically what you do is you fill up the overflow can with water. The water will all pour out if it goes above this spot. When you're ready to place the object in, you place the collecting can right underneath the spout here. You place your larger object in. Whatever water it displaces fills up the collecting can. Then you could pour that liquid or that water from the collecting can into a graduated cylinder and measure it very accurately to determine the volume of that larger object. So just to recap, when we make a direct measurement, there are some things that we need to remember. We measure matter directly. The objects must have a regular shape. You can measure the volume of one liquid directly. You use a ruler to measure a solid and a graduated cylinder to measure a liquid directly. If you're using a ruler, your units are going to be in cubic centimeters. And if you're using a graduated cylinder, they're going to be in milliliters. If you're making an indirect measurement, you're going to measure the displacement of a substance or water. Another name for indirect measurement is called the displacement method. We use this type of measurement to determine the volume of irregular shaped objects, meaning objects that are bumpy or round or don't have equal lengths, widths, and heights. We use graduated cylinders and overflow cans to determine the volume of the liquid that was displaced by each object. And we record those values in milliliters. One last thing to remember is that 1 milliliter equals 1 cubic centimeter. That's all we have for today, folks. If you have any questions when you're working on your labs and activities, please feel free to ask. We'd be happy to explain it to you. Have a good night.